Yes, but before that, I want to know whatever the topics we covered through video lectures, recorded video lectures, and such online sessions, and that recording. Paper one, nearly we are going to cover. Next week, probably we are going to cover the paper one study. Next week, which of the two lectures are there? No, within that, I'm going to cover paper one study. What is left? Electron gain enthalpy, electron negativity, these properties, their variation, and measurement of electronegativity by Mulliken method or Pauling's method or Alfred Rockow method. That portion I have to cover, and for that, I'm giving next week complete period for discussion, and little half an hour will be left. In that we can have the discussion about the questions on what the paper 2. Further one more lecture will be needed, because I told you that for paper 2 study material is provided, instructions are given. Even though if you have doubt, then we can have the discussion. Now Vaibhavi is with the question about the inert pair effect. I want to talk on that. Before that, just I'm sharing with you the learning that I had just before few minutes. Means I was attending that the workshop. So expert from Chandigarh, what was he saying? Currently, our education system is focusing on the left part of the brain. There is a need of the time to work on the right part. Rightly, we should focus on the use of the right part. And what is that right part? Right part is a conceptual, or it is a problem solving part. If we want to be a successful in a life, let any field you are what choosing, you should be the problem solver. And for that, we have to train that brain. We have to train that part of the brain. And that is possible by a question that you are asking, as like Vaibhavi had asked a question. That's a curiosity. Question answers, concept grows. Concept grows, you can apply that concept. You can apply that concept to solve the issues or solve the problem. Many are not habituated to do that. If you are not getting or finding the questions, yes, students, it's a time to think on that. You can score good. You can be in the merit, but in future you want to be a successful. For that, it's the right time, it's the right age for you, where you have to think about the use of the right part, and that deals with problem solving. To solve the problem, concept should be clear, application approach is what necessary. So there you have to have the work to train your right brain. So if time permits, later on we can have the further more discussion about that, about the right brain use. Just I was working on one book, just I'm going to write that there, where I'm finding how to learn, or learning is actually anybody could do, but we made it specific. It is a problem that I was with that conclusion. But today, whatever the lecture I attend, from that whatever I was thinking, it is fixed. It is what correct, that ceiling that you can say, that I could able to find from that discussion. But later on in detail we'll discuss. But let us talk about this chemistry aspect. It's a inert pair effect. But before that, whatever I told you, is it clear?
Yes, sir.
Yes, sir.
Yes. Now I will show you the presentation on whiteboard. Actually, whiteboard you can open on your mobile through link also, or directly how I can share the screen. Through that also you can find the whiteboard. Just wait. Let me share the screen also, so that you need not to download, because for that a jam is one application. Maybe other teachers are using, you maybe with that app. If you are with that app, you can see that whiteboard on your device. Could you able to see the whiteboard now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Good. See, the point or question asked is about inert pair effect. So what that inert pair is? Let me take example of, say, group 13. Group 13. Will anybody answer what is a general electronic configuration for this group 13 elements? Noble gas certainly will be there. Let it be the helium, neon, krypton, xenon, or radon. Noble gas configuration. After noble gas, what will be the electronic configuration for group 13? Boron is a one of the example. Below boron, which element is there in that group 13? Boron is a one element. Below boron, which element is there?
Aluminium.
Right, aluminium. Yes, below aluminum, which is there? Will anybody answer?
So Genadium or Giladium.
No, no. Okay, spelling is somewhat right. Miss, you might be knowing the symbol. It's a gallium.
Gallium.
Gallium. Okay, so these elements are there in group 13. I want to know what is their general outer electronic configuration. Here I represented noble gas. Example, if I take a boron, then there will be the helium followed by. I want this electronic configuration here. Yes. What's electronic configuration? It's a N means outermost shell. Yes. N. Which orbital shall I consider here? Which sub-level shall I consider? Just consider boron. After helium, in which orbital electron will enter?
S, sir.
Right. S is a correct answer. Ns, and accommodating capacity for that S is 2 electrons. After Ns, which may be the orbital? N. Which orbital?
NP.
P.
Right. Np. Now I
3.
want answer from you. How many electrons may be there in that p orbital?
3.
3 electrons.
Think properly. We are talking about, say, example boron. Total 5 electrons are there. Helium is there already. Helium has consumed. Helium has taken electrons within itself.
1.
Right. Helium has taken 2 electrons, and now what was the answer that I found? That's a 1 electron is present in that NP orbital. Am I right? Are you following?
Yes,
Yes,
sir.
sir.
Yes. So total there are 3 electrons in outermost orbitals of group 13 elements. So if by any means that element has to give the electron out, then that boron will say, I have the property of 3 electron. I can give 3 electrons out. First, which electron will go out? Electron from last orbital. That's NP electron will go out. Then which electrons will go out? Electron from NS will go out. Means sequence of going out, I am saying. Sequence of ionization. Sequence of removing the electron about which I am talking. Are you following what I am saying?
Yes,
Yes,
sir.
sir.
Good. Only I am asking question to know whether you are alert or not. Okay. So total 3 electrons are there, and those 3 electron can go. So roughly anybody easily can conclude that 3 electrons are there at outermost shell. So 3 electrons can go. So this group 13 elements can show plus 3 as a oxidation state. It is true, absolutely true. But as we go down in the periodic table, then we find that tendency to lose this electron from p orbital, yes, is there everywhere. So everywhere in the sense what this you can say about gallium I represent here. Example, it can show plus 1 oxidation state. When will the gallium show plus 1 oxidation state? If last electron which is in the NP orbital goes out, ionizes, then it will show plus 1 oxidation state. But when it shows the removal of 3 electrons, then it will show the plus 3 oxidation state. As a practice, we find that boron can show plus 3 oxidation state, aluminum can show plus 3 oxidation state. Actually, tendency to show plus 1 that I represent by the other style. Tendency to show the plus 1 oxidation state, plus 1 oxidation state is very poor, or you can say it is nearly no. Tendency to show plus 3 is large, predominant. But as I go down, tendency to show plus 3 is less and plus 1 is more. More and more probability will be there to show the plus 1 oxidation state. It is our practical observation. How to solve this problem? How to explain this problem? For that, the concept asked by Vaibhavi is there. What is our problem? For upper elements, we are finding plus 3 as a stable oxidation state. And for lower elements, we are finding plus 1 as a stable oxidation state. And it is because of which phenomenon? Inert pair effect phenomenon. Means what exactly happens? Out of those, just I clear this board now. Out of the 2 electrons present in what the NS and only 1 electron present in the NP, we find as we go down, the electron in NP goes out, but electrons in NS, they do not go out. They hesitate to go out. If they are hesitating to go out, if there's a problem to remove those electrons, then that oxidation state will not be shown. These electrons will not come for our help. As if like inner core, inner electron, those electrons will be there. Only one electron will what the go out, and which will be the predominant oxidation state, plus one will be the predominant oxidation state. Predominance of lower oxidation state, predominance of plus one oxidation state for group 13 elements is due to inert pair effect. Which is that inert pair? This is inert pair. These two electrons are there. That is our what the inert pair. So those two electrons do not go out. Inert means what? Not interested to react, not interested to go out. That tightly bounded. So there, those are what the inert. So the pair of electron present in the ns orbital, which is inert, due to which electrons are not involved, due to which those electrons are not coming out, means only other electrons. So NP electrons will go out. So that tendency of element to keep those two electrons inert, to keep those two electrons tightly towards the nucleus, hold it towards what the nucleus, that tendency gives birth to the effect called as inert pair effect. Because of this inert pair effect, see, I'm going to sum up. For group 13 elements, we are finding plus 1 is a predominant oxidation state as we go down in the group compared to plus 3. Is it clear?
Yes, sir.
Yes. Then answer for my question. If I consider group 14 elements, then as I go down in the group, which oxidation state will be the stable? In case of group 13, it was plus 1. In case of group 14, it will be
Plus 2.
brilliant answer, plus 2. And which will decrease? Whose stability will decrease? Previously plus 3 was there. Now what will be there? In case of group 13, plus 3 and plus 1. Now for group 14, plus 4. See the difference here. What's the difference? How many electrons are differing? Two electrons. Those two electrons are present in the inner s orbital. So ns2, that's inert pair phenomenon. Are you following?
Yes, sir.
Yes, sir.
Yes. Now answer for my discussion. If I consider a group 15 elements, then as I go down in the group, which oxidation state will be more stable? For group 13, plus 1. For group 14, plus 2. Now my question is about group 15.
Plus
3.
Right. And whose stability will decrease as I go down?
Plus 6. Plus 5.
Right. Plus 5. Now see the difference within these two. It's a difference of 2 electrons. And those 2 electrons do exist in the ns orbital. And those are paired strongly. Those are inert. Their inertness shows this behavior. That's our inert pair effect. So Vaibhavi, your question was regarding the inert pair phenomenon. Is answer for the question clear?
yes, sir.
Other students, question asked by Vaibhavi and answer I provided. Is it clear?
Yes,
Yes, sir.
Yes, very good, very good. Yes. Any other question? Anybody has any question? Yes, Vaibhavi.
So, what is oxidation potential value?
Oxidation potential. You're talking about physical chemistry, it's electrochemistry point of view.
नो सर तुम्ही जे PDF पाठवलेले ना ते रीड केल्यावर मला हा क्वेश्चन पडला.
Okay, there. That point also we are discussing. That this point will help us for paper 1 study also. I come to that point. Yes, Vaibhavi, I'll discuss that point. Meanwhile, any other question?
No, sir.
No, sir.
Yes, students,
No,
be
sir.
courageous, say clearly. Good. Okay. Actually, I'm discussing for this paper, no, paper 1, ionization potential, or ionization energy, or more correctly. Yes, can anybody answer? What is that? In spite of ionization enthalpy, what we say? Physical chemistry term we apply. Yes, at least complete now.
Enthalpy.
Right, enthalpy of ionization. In true sense, all these 3 terms are different, but we understand them as what the same. I want to bring your attention to the basic approach. What potential is. In physics, you might be studying the potential. Have you heard this word potential?
Yes, sir.
how we represent that potential term? Which symbol we use for the potential?
K.
Which term you are applying? No. In
So
physics, you might. Yes.
delta.
No, delta is for variation, change. It can be delta
E.
I. Yes, yes. Potential for that E can be used. Actually, it's a EMF, electromotive force. It means his answer is somewhat near, but not perfect. Ohm's law, in that, in spite of potential, he used other term. What is that? One part of that letter I represented there.
V.
Right. It's a V. Voltage that we say, no, voltage is related to potential. Potential in literature point of view, it is the ability to perform the work. It is a voltage, high voltage wire, high voltage field, high voltage current that we say. Actually, current means that's a I, resistance R, and potential or voltage, different things are there. But current and voltage are related. Ohm's law, there you might have studied that. Why I'm saying this? This potential, that term is what used. It indicates indirectly E, indirectly other E. That's energy. It is an indirect measurement of energy. Energy term is different, heat term is different, but heat and energy, how are they related? Likewise, energy and this voltage or potential are related. So potential is an ability to perform the work, to do the work, to fetch the current, to allow the electron to flow. And flow of electron is nothing but the current. My point of interest here is to explain you the term potential. So it is the measure of ability to do work. Work I represent as W. Are you following what I'm saying?
Yes, sir.
Okay. Ability to perform the work. That's our potential. So when people were working at the beginning, they were using the electropositive material. But a plate remains, that's electropositive material. And other were electrodes were there. So it was attached to the batteries, you can say. And electrons are coming. So here may be the positive terminal, that can be negative terminal. So charge here will be positive, and here can be what? The negative. As the potential here increases, here potential increases means what? Voltage increases. What is it? It's a battery. It's a source for the power, you can say. Actually, power and voltage or potential terms different, but similarity, synonymically, we can what? Use them. As the potential increases, the electrons then slowly will come towards what? The positive charge, and electric circuit will complete, and we will find a loop. We will find a, if you take a galvanometer or measurement, you will current completion that you will realize. But minimum potential we need to what? Apply. So how much potential is needed to remove that electron that people at the beginning were studying? Therefore, in spite of saying energy, the word used and question asked is ionization potential. Actually, that energy is in terms of the potential. Yes, could you able to sense what I'm saying?
Yes, sir.
Okay. So
Yes, sir.
ionization potential means what? It is a energy needed to remove electron. In order, there will be positive charge to the element. But already positive charge is there, more positive charge will be there. Means if I take a element, say sodium, then if I remove one electron from this sodium, I will get one ion. That is what? Na plus. Energy needed to remove this electron is ionization energy. Potential needed to remove that electron is ionization potential. Enthalpy needed to remove that electron is enthalpy of ionization. Only it's a game of words. But concept is what? Energy is used there. Potential is used there. Enthalpy change is occurring there. Are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Good. If I take say calcium, then I have to remove 2 electrons total. Then I will get a ion, say calcium plus 2. Just during the course of discussing the inert pair effect, I discussed the element, say gallium. So from gallium, I can remove 1 electron, or from gallium, I can remove 3 electrons. So that gallium will form gallium plus, and here gallium will form gallium plus 3. But if I take say gallium only, gallium plus only, positive, then from that gallium plus, I have to remove further 2 electrons. Then I will get this gallium plus 3. So from positively charged ion also we can remove the electron. But for that more potential you have to apply. Previously only gallium was there, only metal was there. It was easy to remove 1 electron. But if gallium plus obtained, then from that positively gallium, removal of electron, more and more energy you have to apply, more and more potential you have to apply, more and more enthalpy change will be there. So that is the concept of removal of electron. Then your doubt further may be, why are we studying this all? See, we are discussing the chemicals, we are discussing their behavior, and these elements do show the variation in their behavior because of their tendency to lose the electron or gain the electron. But while losing the electron, how much energy needed, that we have to calculate. And scientifically we are studying now slowly behavior of the different ions. For that, in your syllabus, now I'm coming to this paper 1 syllabus. In paper 2 also it is applicable. Those are related. Wherever we ask the question related to the ionization potential, which is there in the paper 2. And by the way, it is there in the paper 1. That's an enthalpy change. And this enthalpy can change during removal of electron also and during gain of electron also. If removal of electron, then positive ion formation. Gain of electron, negative ion formation. Means if I have to talk about the sodium ion Na plus, I need to consider removal of electron. But if I have to talk about the chloride ion Cl minus, I need to think about the gain of the electron. Anywhere, let you remove the electron or to gain the electron, there will be change in the enthalpy. Enthalpy is not energy, but it is the most scientific term there toward the use. Not necessarily electric field we are applying. By means of electric field, we can remove the electron. But by means of thermal energy also, we can remove the electron. So different ways are there. Anyhow, energy you have to provide to electron. If electron gets more energy, electron excites, and one time it says goodbye to this atom or even ion also. Accordingly, as like those things went out, means from globe, something went out. Likewise, something can enter in the globe also. While entering the out electron, foreign electron, extra electron in the atom or even ion also, there also change in the enthalpy remains. Enthalpy is a measure of, yes, will anybody answer? Enthalpy is a measure of enthalpy
Heat.
that we represent as what? Yes, enthalpy is a measure of.
Heat.
Right, brilliant answer. See, it's a basic. If you remain only to this memorization level, you are using only your left brain. I want you to be wise. I want you to be a scientist. I want you to be a developed person. You have to apply this concept and you have to practice that. Memorization is information that easily you will get. Yes, is a measure of heat. Okay, I'm not completing this statement. Is a measure of heat. Enthalpy is a measure of heat. Heat is a form of energy. Okay, so enthalpy change remain during ionization to forming positive ion, and enthalpy change remain during the formation of negative ion, during the gain of the electron. Now I want to know the answer from you. If I have to obtain a positive ion, say Na plus from Na, just tell me, I need to provide energy or energy will come out?
Energy come out.
See, what are you doing? Just logically let us think. Sodium has 11 electrons, Na plus has 10 electrons. Means what you did, one of the electron, you have removed. To remove electron, you need to provide energy or energy will come out. That's my question.
We
We
need
have
to
to provide
provide energy.
provide energy.
Right. So what I did now, previous answer also was spontaneous. Proper answer, proper but wrong answer. But attempt was very honest. I appreciate that. But if you think little logically, no, if you work on that, then you'll find okay, Na plus means positively charged ion obtained. Positively charged ion obtained means electron is less. Electron is less means electron is removed. To remove that electron, you need to provide energy. Yes, is it clear to you?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, you need to what the provide or you need to what the supply the energy. Other hand, if I take say a chloride ion formation, means chlorine atom, and from that I am going to obtain the chloride ion. Then when that chlorine atom will take one electron, then this chloride ion will be the result. So when it will take electron, at that time what will happen? Already chlorine was with the 17 electron, but here one more electron has entered, and whichever electron has entered, of course it has negative charge, and that negatively charged electron will remain binded, will remain in attraction to the nucleus. No doubt that nucleus has only 17 protons, 17 positive charge, no problem, 17 positive, but 18 electrons are there. Number of electrons, if are equal, then it's an atom. If they are not equal, then it is an ion. Number of electrons and number of protons I am saying. 11 protons, 11 electrons, atom. 11 protons, 10 electrons, sodium ion, Na plus. 17 protons, 17 electrons, atom. 17 protons and 18 electrons, electron is extra, it is ion. But whoever electrons are there, those electrons are attracted, those electrons have attraction with the nucleus. Just answer for my question. Attraction, friendship, bond formation are somewhat similar. Animosity, distraction or removal or bond breaking, those are similar. I repeat, attraction, friendship, bond formation in one category. Other category, animosity, you can say, or there's no attraction. Repulsion is the best word. Repulsion and not friendship. Your animosity is there, and bond breaking. All are what the similar. Why for I'm saying this? So that comparison will help you to understand the concept. Just answer for my question. If there is a friendship, if there is a attraction, there will be happiness or unhappiness.
Happiness.
Right. Happiness, satisfaction, stability. See, when can one be stable? Low energy, peace, calm and quiet. And energetic may be there, but peaceful. Active will be there, but peaceful. So that is a stability. So wherever there is an attraction, wherever there is a friendship, where friendship remain, actually the power increases in multiple times. I'm not saying it doubles. 1 and 1 becomes 11. Power increases. Likewise, if I come to chemistry, when two hydrogen come together, I'm saying together means there's a bond formation. Means wherever there is a bond formation, answer for my question, there's a stability. So in order to get the stability, energy has to go out or energy has to be absorbed.
Has to be absorbed.
Okay. Think on that. Logically, you have to think. Therefore, I have given different examples. Is my question clear, or shall I repeat the question?
Sir, please repeat the question.
Yeah, listen carefully. Listen carefully. Now, I told you about the attraction. I told you about the friendship. I told you about the bond formation. It is a one category. Other category I am coming later on. My question is, during attraction, during friendship, during bond formation, there is a loss of energy or there is a gain of energy. Ultimate answer is stability. Ultimately, you are getting stability, and stability is a state of low energy or high energy.
Low energy.
Yes. So accordingly, think and answer the previous question.
Sir, loss of energy will be there during bond formation.
Right. So that you might have by hearted. Now I am bringing to the concept of clarity. Stability will be there. Stability is a purpose of life. Stability is the purpose of chemistry. Stability is the purpose of reaction. They want stability. Gives energy change and all those are there. All things are related toward the stability. So in order to govern the stability, there should be loss of energy. So what I want to say, if there is attraction or there is a bond formation or there is a friendship, what is to be done? There should be the loss of energy, then that those things will occur. If somebody gives unconditional or that you can say donation, giving approach, then only friendship will develop. Human perspective point of view, many angles are there. So in general point of view, I'm saying, even in bond formation, when two atoms come together, as soon as they come together, they are together will be revealed by means of their donation, by means of giving energy. And when they give up the energy, they become peaceful, they become calm, they become stable. And for that, the world is struggling. World wants stability. Yes, is that concept clear?
Yes, sir.
Yes, sir.
So what is the conclusion?
Yes, sir.
During bond formation or during attraction, there is a more stability. Energy has to come out. So when anion forms, foreign electron comes, means your F.Y.B.Sc group is there. In your F.Y.B.Sc group, one student from IT department or computer science department come is an extra student. But even though as a student he will remain there within you, means whatever that work is there, friendship may what the possible. I'm not talking about electron friendship. I'm talking about the friendship with the nucleus, which are tasks you are doing. That task the student can also what the perform. So that task means nucleus and our teacher and the electron, teacher and the student, there will be what the attraction will be less, but will be there. And because of that attraction, extra attraction during formation of anion, energy will come out. That is called as enthalpy change during electron gain. Electron gain enthalpy change. So if electron gain is there, answer for my question. Electron is absorbed, electron is taken, new attraction is formed. Net result will be loss of energy or gain of energy.
Loss of energy.
Any more? Are you understanding my question? One answer. Say, I'm not happy with the one answer.
Yes, sir. Loss of energy.
Yes. When there is a gain in the electron, energy will be lost. And that energy is called as enthalpy change during electron gain, or it is called in general way as electron affinity. Is this point clear?
Yes,
Yes,
sir.
sir.
Now, if there is a loss of electron, means you have to remove the electron. In such cases, tell me, means your group is there, F.Y.B.Sc group is there, and one student is saying goodbye, is going out, or is removed by some any means, is thrown out from the class. To do that, what is necessary? We have to provide energy, or energy will come out.
We have to provide energy.
Yes, you need to provide energy. That's the only difference in the electron gain enthalpy, means enthalpy change during electron gain, and enthalpy change during electron loss or ionization. And that point we are what discussing. So in short time, I give the periodic trend for that property, and then if you have any doubt, we can what discuss. But this much answer is there for question asked by what Vaibhavi. She has asked a question regarding what the ionization potential. But what I did in addition to that, I added electron affinity concept also. Vaibhavi, is that point clear?
Yes, sir.
Yes, further, if any student is with a doubt, then we can have the additional discussion. Let me complete this point now. I want to talk about the periodic trend. And let me take one property. And that property I want to consider here as the enthalpy for ionization. Enthalpy change forward the ionization. If you consider the elements in any group, say the first group, hydrogen is there, its chemistry different, so we are considering it separately. Lithium, sodium, potassium, rubidium, cesium, and last is what the francium. As you come down, what do you find? Atomic size increases or decreases?
Increases.
Yes, it will what further go on, it means it will increase further, large, it increases. If atomic size increases, then removal of electron will be easy or difficult?
Easy.
Removal of electron will be easy. See, less number of students, teacher can pay proper attention. More number of students, if number of students 10, 20, 30, 100, then large number of students are then to last bench student, teacher can't pay the proper attention. Student may also be not with attached to that discussion. So it is easy to remove that one electron. Somebody from the door can come and can remove that electron. It is what easy to remove the electron. So it's the first conclusion today we are drawing out. As we go down in the group, enthalpy for ionization will increase or decrease? Enthalpy ionization will
Increase.
it is easy, no? To remove electron is easy. So enthalpy for ionization will
Decrease, sir.
right, decrease. It is our first conclusion. Now, second conclusion. For that, we have to consider period, means the elements in a period. So the second period, let me consider. Say lithium, then beryllium, then boron, then carbon, then nitrogen, oxygen, fluorine. As I move from left to right, atomic size increases or decreases?
Decreases.
Decreases.
Yes, atomic size goes on decreasing. It decreases. Atomic size decreases. As size decreases, number of students decreases. So focus, attention from nucleus will be strong. So enthalpy change for ionization will increase or decrease?
Increase.
Increase.
Right. So it is my second point of discussion. First point was as I move from top to bottom along a group, enthalpy for ionization will decrease. Reason is increase in size. Reason is shielding effect or screening effect. Means which is the many electrons are there, no crowding will be there. Electron, they will not quarrel. So last electron can easily move. Total net attraction or decreases. Okay. Other. As I move from left to right in a period, atomic size decreases. Atomic size decreases, attraction increases. And by the way, there's no more effect due to shielding or screening because electrons are added in the same shell. Therefore, more effect of shielding or screening is not there. Therefore, as we move from left to right, the ionization energy or enthalpy of ionization or ionization potential increases. Is this point clear?
Yes, sir.
Yes, sir.
Now, because of your answers, I want to conclude the point related to enthalpy change, electron gain enthalpy. As I move from top to bottom in along a group, what do you think? This electron gain enthalpy will increase or decrease? Means
Decrease.
attraction to electron addition. As
Decrease.
more,
In
yes, say please.
increase.
Electron gain enthalpy will increase. Timing I write that. Whatever answer you are writing, you are saying no, you are saying increase. I want to verify that. Just help me. Atomic size increase or decreases?
increases.
Increases.
Yes, increases. So entry of electron strongly where attraction as electron enters, where will be the strong attraction? In this case or in this case? Strong attraction I want. As new electron comes, 100 students are there and in that 101 student came and only 2 students are there, 3 students are there, and that one more student came. So where will be there more attraction? Fourth student will experience more attraction or 101th student will experience more attraction?
4 students can face more
Yes, that both
attraction.
students should experience the more attraction. Other students, are you getting this logic?
Yes,
Yes,
sir.
sir.
Yeah.
Yes,
So
sir.
that students experience more attraction. More attraction means that much amount of energy will come out. I repeat, here in such cases, less number of electrons are there. Less number of electrons. So if one more electron comes out there, strong attraction will be there because friends are less. But when large number of electrons are there, in that if anybody comes out there, then it has not that much affinity, that much attraction from nucleus as was there in the less number of electrons. Means when now it's a lunch break, maybe I don't know exactly, but if you are hungry and if you get a one chapati, okay, you will eat it fastly. Attraction is there more. But after taking the sufficient quantity of chapati, if extra chapati come out there, then you will say it's not fair. It's better to not to have that. Or even if you take that, with less interest, you will have that. So attraction will be what less. Lesser the attraction, the energy evolved, energy liberated will be less. So what should be the logic here? Electron gain enthalpy will increase or decrease?
Decrease, sir.
Yes. So I have to change that. In spite of increase, the answer will be it will decrease as I go from top to bottom. Now, again, help me. Now you understood the logic. But I want that with understanding, you should apply that logic. As I move from left to right, means from say lithium to fluorine. Why are there many elements? Size of fluorine is small. And here, the size is what the larger. Where will be the high electron gain enthalpy? For fluorine or for lithium?
For fluorine.
Fluorine.
Yes, yes. So here what will be the logic? Electron gain enthalpy will
Increase.
Increases.
right will increase. Reason for that, first logic always remember size. Therefore I discussed at the beginning size. Second logic, keep in mind screening or what the shielding. And third logic, as usual, think whether attraction is increasing or decreasing. Accordingly, the result will be there. And with the help of these 3 logical terms, you can answer the question how the electron gain enthalpy varies, how ionization potential or ionization energy or enthalpy of ionization varies. Is this point clear to all?
Yes, sir.
Yes, sir.
Yes, students. So as a notes, what will you write? You will write the enthalpy change during ionization and enthalpy change during electron gain. What is that and how does it vary? In a periodic table, as I move from left to right across a period and top to bottom along the group. With reason, that is the discussion we did today. And as a notes, you will write that so that We have completed nearly all points. Next time we will discuss effective nuclear charge calculations are there. Interesting calculations are there. And later on, electronegativity point. Then our syllabus of paper 1 will complete in next week. It is my planning. And about paper 2, yes, I'm giving some time if you want. In that week, extra lecture means extra in the sense what? Additional lecture we can conduct and we can complete paper to study in advance. Is this planning and today's discussion clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
very good. Any doubt?
No, sir.
No, sir.
No, sir.
No doubt, sir.
No, sir.
Manthan, Tejas, Mayuri.
No doubt, sir.
No doubt, sir.
Mayuri, had you answered?
No doubt.
Good, good, good. I hope and expect that today's discussion is clear to you. And study well. And remember, use of right brain here. Right brain is very important. Rightly, you have to use the right brain. Therefore, always I ask the question for that. I'm not interested in your memorization more. It is needed to one level. Application is the most important. Even if you want to be successful in competitive examination, any field in the life, that is the most important thing. Okay, students, if you have no question, then shall we stop?
Yes, sir.
Okay, sir.
Yes, sir.
Yes, sir.
Yes,
Vaibhav,
sir.
yes, Vaibhav, you are with question. Say,
No, sir.
you raised the hand, so I thought that you want to ask something.
No, sir.
No, okay, no problem. If anybody has a doubt, next time ask the question. See, Vaibhav is asking questions. Further, few students are there, they are regularly asking questions. I want questions from everyone. That will prove whether you are studying or not. And quality of question will decide how will you grow in life in future. Okay, students, I stop the recording and declare here today's session, today's lecture is over. Please quit.